Okay. Um, Hello. I am Zihander C. Sourcing the second, and I will discuss about N-channel enhancement mode metal oxide semiconductor field effect transistors or N-channel MOSFETs. But the discussion will mainly focus on the channel length modulation that happens sa ating mga MOSFETs. Okay. So I have here a visualization of an MOSFET. And an E-MOSFET typically looks like a deep MOSFET. It's just that walang direct channel that connects the N-type regions, itong mga red regions na to. So kasi di ba pag kay D-MOSFET, may channel agad dyan. Okay. It will look like this, diba? Kapag it's uh, a D-MOSFET, pero kapag E-MOSFET, it's just that it's not existing. Okay? Okay. So, uh, let's show yung mga voltages natin. The important voltages. So, here, ito yung drain, and then this is the gate region, this is the source. Let's connect yung GNS natin, and then connect natin sila pareho sa ground. Same here with D. So, essentially, ang gusto natin mangyari kapag meron kang uh, N-channel na E-MOSFET is uh, this voltage right here, okay, must be positive enough such that the electric field from these voltages ay magkakos ng pag-attract ng holes ng ng electrons ng the substrate natin. Okay? So if this region is positive enough, for example, what happens is push yung napupush yung mga holes na nasa na near the gate. Okay? So like may mga holes dyan kasi ito yung majority carrier natin pag P-type ang substrate. So if this is positive, this region is positive, therefore mapupush tong mga holes na to deep into the P-type substrate. Okay? So ang tendency is yung mga electrons natin, uh, sila yung ma-attract near the gate. So magkakaroon ng electrons here. Okay. So dahil merong insulating layer dito, it stops the electrons from moving papunta dun sa ating gate. Okay. So magla-line up lang sila dito sa area na. So this is called the inversion layer. So bakit siya inversion layer? Kasi um, since the majority carrier ng substrate is holes, or since it's a p-type substrate, okay? So this is puro positives or puro holes nandito. And then suddenly you have a layer na puro electrons. So that's just basically the charge of this layer is in the inverse of the charge no substrate. Kaya siya tinawag na in inversion layer. Okay. Okay. So yeah. Uh, I'll just show yung okay. So I created this earlier. Um, the graph of the drain current versus our um VDS. So the drain to source voltage natin with different values of gate to source voltage. Okay. So maybe let's set this at 0, then at 1, at 2, 3, 4. This is in volts. Okay. So as you can see, habang nag increase yung VGS natin, nag increase din yung drain current. But as the VDS increases, this graph shows now the drain current remains constant. So this is what happens kapag nasa ideal world ka, kapag the non-idealities were not considered. Okay, so let's just show muna kung ano yung itsura ng VGS na VDS na to. Okay. So from this graph, so since the source is connected naman sa ground, and so you can let this voltage right here as your VDS. So this is effectively the same, 0 volts. Okay. And then also this is your VGS, the potential difference between the gate and the source. Okay, so but the thing is, uh, kapag the non-idealities were now considered, uh, the graph actually looks like this. Ito lang to, may nating red. Okay, wag lang. Let's say blue. When the non-idealities are considered, so kapag nag increase yung VDS natin, may slight increase siya na dulot dun sa ID. Actually, hindi siya constant. Diba dito? As you can see in this layer, okay, itong portion na to, ito yung saturation region ng ating MOSFETs. So, i-assume na pag nandito na tayo sa point in time na dinidiscuss na natin yung channel length modulation, na-discuss na yung different regions of operation ng MOSFETs. Okay. So, uh, the real the real scenario is that in real world scenarios, kapag nag-i-increase ang VDS, may epekto siya sa ID. Okay? May slight increase siya dito. Okay? Ito yung uh, um, real version when the non-idealities are considered. Okay, this is what you call the channel length modulation phenomenon. Okay. Sorry sa handwriting. Pero yeah. Like that. So, we want na mapakita mathematically on ano nangyayari, bakit kapag nag increase yung VDS, nagkakaroon ng change sa value ng drain current. Okay? Okay. So, dito. Okay. So this is the inversion layer natin kanina. The inversion layer. Itong inversion layer na to is may required siyang voltage para magkaroon ng inversion layer. And that required voltage is VGS must be equal to VTH. Now, this only applies dito sa region na to. Sa region na to. Itong buong part na to. So, ano naman dito sa other half? So ano yung ano natin? Uh, what's the basis para magkaroon ng inversion layer? Dito naman sa other half, ang equation na nag-govern is this equation. VDS is greater than or equal VGS minus. So VTH meaning the threshold voltage. Okay. So if the VDS is equal to VGS minus VTH, and then what actually happens is kapag minanipulate natin yung equation, VTH is equal to VGS minus VDS, or effectively, VTH is equal to VGD. So this is your VGD, right? This is our VGD, the potential difference between the gate and the drain. So if this is equal to VTH, ang nangyayari, so may mabubuo kang channel due to the inversion layer. Straight line. So, pero, this is it. Ito yung ano natin. Ito yung channel na nabuo due to the inversion layer. Okay, pero pag your VDS is, or your VGD is just equal to VTH, what happens is, negligible yung channel na nabuo sa portion na to. Sa portion na to ng, negligible yung width na nabuo. So, it actually looks like this. Okay. So this is what you call the pinch-off condition. This equation right here. This is our pinch-off. Pinch off. Pinch off kasi, as you can see, the width of the channel in this region, no, makapal pa siya, and then habang nare-reach nyo yung um, area near the drain, mas nagiging maliit siya. Okay. Napipinch yung channel natin. Oh, okay. So, ba't kaya siya napipinch? Kasi if this VDS, let's erase this part. If this VDS term is increasing, okay, say this increases, edi your VGS minus VDS, it gets smaller. Okay. So maybe it can also reach negative values. So if this VGD is um is small enough, or another term would be negative enough. So for example, this this region right here is negative enough. Ang tendency is yung mga electrons na nasa inversion layer, it will get pushed off deep into the substrate. Tulad ng mga nangyari sa holes natin kanina. Okay, so if the electrons gets pushed off, of course, ninipis or bababa yung width nung, or yeah, bababa yung width ng ating channel. Kaya parang may portion dito na parang naka ano siya, natapyasan. That's because of that. Okay. So, dito, we can see na as we increase VDS, as we increase VDS, as we increase the VDS value, yung length yung effective length ng channel natin. So, we can say we can say na itong measurement na to is L, and then we can say na yung natapyas na length, let that be delta L, or the change in L. Okay, so as the drain to source voltage increases, yung delta L na, yung nawawala sa channel length natin also increases as well. So, although wala silang linear relationship, pero we can assume na they have linear relationship, but the actual relationship is quite complex. Okay, pero for the sake of this discussion, we will assume na meron silang linear uh, relationship, or maybe they are directly proportional to one another. Okay, so now we will move on sa mathematical part. So we know na for e-MOSFETs, hindi na nag-a-apply yung uh, Shockley's equation natin. Okay. So for the drain current sa e-MOSFET, this is defined as ID is equal to K times your VGS minus the threshold voltage squared. So the K right there is your transconductance parameter. So transconductance parameter. And we can further define K as follows. So ID is just equal to 1/2 mu n C O X W over L times VGS minus TH squared. Okay. This COX right here is our gate oxide oxide capacitance per unit area. Okay. And the unit for this is farads per square centimeters. And then itong mu n is our electron mobility. Electron mobility, and the unit for electron mobility is um hmm, okay, ito. Square centimeters per voltage seconds. Okay, as you can see, gumagamit tayo ng centimeters and hindi ginamit yung SI unit na meter. Why? Kasi um basically the engineers just want to avoid yung very small numbers. So if we will use meters, di ba? The conversion from square meters to square centimeters, they differ by a factor of 10,000. Yeah, 10,000. So, yeah. So this W right here, ito yung width of the channel, and then yung L is yung length ng channel, and then VGS minus VTH. It's good. Okay. So far, so good. But since we are now considering, well, tayo sa diagram natin. It looks messy, pero yeah. So we are now considering tong delta L, right? Okay. So since we are now considering yung delta L, yung bagong formula natin for the drain current must be ID is equal to mu n COX 1/2 mu n COX W over. So di na tayo gagamit ng L since meron ng uh, nawala na length natin, which is defined as delta L. So we will use L minus delta L right here. Then VGS minus VTH squared. Okay, now um the equation still look nice. It still looks nice. So what I'll do is ilalabas ko yung factor na L as follows. And then the reason why is you'll see later kung bakit ko siya ilalabas. So this is just W over L times 1 minus delta L over L times VGS minus VTH squared. Hirap sa online. Should have Sige. Okay. So as you can see, um, itong term na to, this term right here, okay, that term right here, pwede ko pa siyang i-rewrite like this. So, pwede ko ilagay ito na W over L times 1 over 1 minus delta L over L times VGS minus VTH squared. So, itong term right here is crucial kasi kailangan natin siyang i-simplify. Okay? So, we just need to remember yung ating Math 22 topics. Okay? So, from Math 22, we learn Taylor series. So, maybe dito sa kabilang part na lang. Sa kabilang. Like, you have the Taylor series. Okay? So, this is just the summation from n equals to 0 to infinity of the nth derivative over n factorial of x minus a raised to n. Tama ba? I think it's correct. And then, meron tayong Maclaurin series. Okay. Maclaurin series is just the Taylor series centered at 0. So instead na A, we will use 0. So summation lang din siya from n equals to 0 to infinity, nth derivative defined at 0 over n factorial over x over times x raised to n. Okay? So, ang gusto natin makuha is ano yung Maclaurin series approximation for this term. 1 over 1 minus x. Kasi this term looks like this. Itong 1 over 1 minus delta L over L. If we just let x to be delta L over L, they are identical, right? Okay. So basic lang, calculus lang. So kunin lang natin yung well, the zero derivative is the function itself. So define lang natin siya at 0. Okay, sige. So this is your f0, and then let's define the first derivative, maybe the second derivative, just for fun. Okay, so pwede siyang i-rewrite as 1 minus x, no? Raised to negative 1. And then by power rule, wag lang natin to. So this will just become negative 1 times 1 minus x. Tapos negative 2 na to. Then chain rule. Therefore, the first derivative of the function is just 1 over 1 minus x squared. Okay, so let's try i-derive yung second derivative. So the second derivative will just be negative 2 here times negative 1 again, then 1 minus x, negative 3, or 2 over 1 minus x raised to 3. Okay? So, ito lang yung nth derivative natin, and then i-define natin siya at 0. So, at x equals to 0, oh, lalo po. So, at x equals to 0, this just becomes 1. Ito din 1. And ito ay 2. And then, hanggang second derivative lang kasi I'll show later kung bakit di ko na i-define yung mga next terms for it. So, kunin natin yung ano no. Kunin natin yung series set. So 1 over 1 plus x is approximately equal to, so yung zeroth derivative is just 1 over 0 factorial, which is just 1. Tapos x raised to 0 plus 1 over 1 factorial, which is 1, times x raised to 1 plus 2 over 2 factorial, which is 2, times x squared. So 1 over 1 plus x is approximately equal to 1 plus x plus x squared. Well, this is precise to such an extent basta yung value ng x natin is very low. Kasi ilang terms lang ng series yung kinuha natin. Okay. So, the third term, actually, di natin kailangan yung third term na x squared. Why? Kasi yung x natin, di ba? This is just your delta L over L, if you remember. If that's the case, and this delta L compared to L, it's a small number. And then a small number divided by a large number. Well, the quotient to be a small number as well. And then kung i-squared pa natin yun, that will become very small such that magiging negligible na siya. Okay, so we will not use the x squared term. Interested lang tayo kay 1 plus x. Now, see 1 over 1 plus delta L over L. Sulat ko. 1 plus delta L over L is just approximately equal kay 1 plus x, which is 1 plus delta L over L. Okay, so this term right here is just equal to this. Na-prove natin siya using Maclaurin series. Okay, so we will use this term na and then plug it in sa ating equation. So we will not use this term. So i-write natin yung formula for our drain current. So dito na siya. 1/2 mu n C of x W over L times VGS minus TH squared times 1. Ayun, yung kanina. Ulit yan. 1 plus delta L over L. Okay. 1 plus delta L over L. Okay. Now, as I've said earlier, delta L, meron siyang relation kay VDS. Ito. Ito kanina, sinabi ko. Okay, sabi ko kanina habang tumataas si VDS, kasi habang pinapataas ko tong VDS na to, okay, if this value gets higher, then yung difference between the VGS and the VDS, it gets lower. So, ang tendency is magiging negative tong area right here. And if magiging negative tong area right here and meron akong P-type na substrate, matutulak ko yung holes deep inside the substrate. I mean, matutulak ko yung electrons deep inside the substrate. Then, yeah, magkakaroon tayo ng depletion region right here. Okay. So, if they have some sort of relation, let's assume that relation is they are directly proportional to one another. So, meaning, ang assumption will be the delta L over L is directly proportional to VDS. Okay. So, we just multiply a certain factor kay VDS para makuha si delta L over L. And for that, we will use lambda. Lambda, delta L over L is just equal to uh, lambda times VDS. Okay. And this lambda right here is what we call the channel length, channel length modulation coefficient. Okay. And the unit for this is voltage or volts raised to negative 1. Okay. So, yeah. From there, we just substitute instead na delta L over L. We can now rewrite yung final equation ng drain current natin to be, no? Na kino-consider si VDS, no? Dahil sa channel length modulation. CO is W over L times the gate to source voltage minus the threshold voltage squared times 1 plus lambda or the CLM coefficient BTS. Okay. So basically, itong 1 plus lambda VDS na to, ba? Lambda is V, negative 1, and VDS is in terms of V. So they will just cancel each other out. Magiging constant na lang. And then 1 plus a constant is obviously a constant. So, ano lang, factor lang to. Napapataas na. So as VDS increases, no, kung tumataas tong value ng VDS na to, obviously, tataas din yung value ng ID natin. So, yun yung gusto nating behavior from the start, di ba? Yun yung gusto nating ng ideality na ma-consider mathematically right here, no? So natin na habang tumataas yung VDS value natin, pati yung ID tumataas din. Okay? May epekto siya sa ID. Okay. Pero if this guy here gets pinched off, bakit kaya tumataas yung current? Pero it doesn't make sense kung nag-pinch off tong area na to. Dapat lumiliit yung current kasi para siyang nag-serve as a resistance. Di ba? Well, not necessarily. Yung pinch off right here doesn't mean a cut or a break dun sa channel. Okay? So, what actually happens is, okay, okay, um, there is an existing electric field here, no, this portion. The effect is that kahit napipinch off yung electrons dito sa area na to, near the drain, um, nasa-suck in or nata-transport ng electric field, nahahatak ng electric field yung mga electrons pa dun through that pinch off area. Okay? So, why is that? So, a little bit of electromagnetics lang. Just remember na yung E natin is just the E is equal to negative nabla V. And this nabla right here, this means the gradient. Okay? So, gradient meaning E, electric field, is just equal to the partial derivative of V kung we are talking about um, a three-coordinate system, X, Y, and Z. So, the partial derivative of V with respect to X, I hat plus partial derivative of V with respect to Y, J hat plus partial derivative of V with respect to Z. Shucks. with respect to Z, K cut. Okay, pero the thing is, we are only considering itong difference na to. Okay? So that's just in one direction. Yung length lang. Ayan, maliit na length lang. So we can say na E is just equal to negative dV over dx. And then this dx right here, yung delta L natin. Okay, if this value here stays the same, and then this value here is very small, so what happens? What happens is, meron akong malakas na electric field. Okay? And if malakas yung electric field mo, mas malakas yung hatak mo ng mas malakas yung tendency mo na hatakin yung mga electrons na nagfo-flow dito sa pinch of area na to. Okay? Kaya nagkakaroon ng slight increase in current. Okay, I think that's it. I think I've discussed all I need to discuss. So yeah, thank you.